Hi guys. So here we have our Excel sheet for our sports game. So as you can see, this is our interface page. So this is where we'll be giving our inputs, by which we can see how the resources are going to be distributed based on player profile and some factors based on which the game is going to be designed. So some of the factors which we are giving here is the base level up experience, like how much experience initially a player is to be given, based on which we can divide the level curve increases or decreases. As you can see, this is an input taken from here. So if I go ahead and change this to 700, so this, as you can see, just changed, and the number of experience required actually increased. So same goes for starting gems. So this is an input over here, and based on which the factors are going to be decided. And starting coins, so coins does not have a separate Excel sheet, because coins are some resources which we are not going to be closely monitoring. We are going to be giving it in a very lenient manner, but where there are very limited stuff which the player can actually do with the coins. So here we have the player profile. So here basically these inputs will decide how which kind of player you want. Say if you want a really good player, you can set the win percentages to say about 80. So if you say 80, he just increased in level, right? So before he was, let's go back to 50. So he, as you see, he was at level 7. So of course, if he wins more games, and he will get more experience, and he'll be in a higher level with higher number of resources. So based on how you want to design a player, you can give these input and mimic an actual real world player, and we can see how the resources are going to be distributed. So this being a dual economy, we have two types of resources. One is coins and one is gems. So the this accounts to the total number of gems. So gems can be either bought or can be won in game, and there are some gems which will be given to the player while he opens some chests. So let's go ahead and try to buy some gems. As you can see, these are the only denominations we currently allow. So let's start with the smallest denomination, that is 0.99. So this shows how much gems we can get and how much is the value being given over here. So let's try the highest amount now. So that is 49.99. Yeah. So as you can see, the gems per dollar has increased quite significantly. So and let's say an average player spends about $5 in this. So let's go 4.99, and you buy the gems. Now you can see how much gems he has bought, and based on this gems you can actually buy resources from the stores, and these can be translated into cards or any other resources which are going to be designed. So I will give the stage to my teammates. They're going to explain the individual graphs in much more details. Thank you.
Wait, I will introduce the gems and store tab for you. Firstly, you can see player's current state and resources in the interface tab. Player level is the current level of players. Total gems and coins is the resources they have. And you can also check how much money the player has spent on this game. Gems has a distribution among levels. For each level, you can see how many gems a player can get, and the cumulative gems of current level. Well, gems can be bought by real money, and coins can be transferred from gems. In the Store tab, your input can be money or gems, which represents using money to buy gems or using gems to buy coins in reality. The first table shows with the increasing of money spent, gems become cheaper. That is, gems per dollar is increasing too. You can input feasible value of cost dollar from this column in the Interface tab and click on the button to buy gems. I will explain this later. Well, for the second table, it shows you transformation from gems to coins, which has a constant proportion. Gems and coins are very important resources in the game. Players can use them to buy chests, and different levels of chests will provide different rewards. For example, gold chest can be bought by 120 gems, and it will give you 1 gold cards, 2 silver cards, 3 bronze cards, and 12 card points. Here is a graph to show the distribution. Okay, let's go back to the Interface tab. As I have mentioned above, you can use a button to buy gems. You can input a feasible value from the table and check how many gems you can get in this price. Let's give an example. If you input 0.99 and you can get 20 gems, you think you need more gems with a cheaper price, so you want to use 2.99, and you think this price is good, and so you buy gems, and you can see the increasing in total gems and money spent.
This is the economy of a sports game that we have developed. I have developed the cards tab, and I'm going to show how this cards tab work and how the economy can be used for any sports, any card-based games. At the first, we have interface, and here, according to the player level, we are calculating the card points. I've used the function sumifs for card points, which is using the cards tab to calculate how many total card points are there which a player has at a particular level. Now, card points are used to upgrade a card. So if a card is at level 1, if a card, then that's just one card point is required because every card would be basically at level 1. If a card is at level 2, if a card is at level 1 and you want to make it to level 2, then we can use 2 card points to upgrade the card from level 1 to level 2. So this is the distribution of how we are leveling up the cards using card points, and this is the graph showing that. Now, at every player level, we are giving some amount of free cards to the player. There are 3 types of cards in this game. There are gold cards, there are silver cards, and there are bronze cards. And each card has a particular card level. The player levels and the card levels are completely independent of each other. In this game, we have just 17 levels. So we've distributed how many free cards we are giving in this game according to the levels. So gold cards are super rare, silver cards are rare, and then bronze cards are given frequently. At level 10, the player gets one gold card of level 4. So the gold card is has card level 4 and is given at level 10. We also give one silver card of level 4 and 6 bronze cards of level 4 at the 10th level when the player completes the 10th level. So the distribution is like this. At 10th level and 17th level, you're giving one free gold card of particular levels where the player is according to that. Silver cards are given more frequently than gold cards, but still not as frequently as bronze cards. So bronze cards are given like 3, 2, then 3 again, and the level increases and then it decreases. And we just made a simple function to find out how to distribute these. While silver cards and gold cards, we're using round off functions to give it at some particular levels, like gold cards are given at 10th and 17th level, silver cards are given at every 4 levels, every 5 levels, sorry. So 5th level, 10th level, 15th level, and since 17th level is the last one, so in the 17th level. This is distribution of free cards. These are the card levels, and then it's according to the card levels how many gold cards, silver cards, and bronze cards we are giving. Now card point, how many cards a player has currently can be calculated using these card levels, and what is the current player level. Since we know the player level, we know how many free cards he has. So just use sum if s function to to give a sum of all the gold cards and the card level of the gold cards, because here we are not considering player levels, this is just card level. So which level cards a player has and which type of cards the player has. So since the player is at level 10, so thus he has one gold card of level 4. Now we've given two silver cards by now, 5th level and 10th level. So one silver card of 2nd level and one silver card of 4th level, and that's what he has. And the last is bronze cards of different levels. And the distribution is over here on how the player has different types of cards at his particular level. And this player level is derived from interface. So we know the player level. And again, the card points is derived from this part. So we know how many card points a player gets for each card level. So that's how we are giving him the card points. And we are also using the starting level like experience, win percentages and all to find out how many card points a player will get at one point of time. I hope this has been informative enough for you. Thank you.